So in this video, we're going to talk about Gaussian elimination. So we kind of did a little bit of solving a system of three variables and three systems using a weird version of Gaussian elimination. But you can see that one of the things that was really difficult is that, first of all, we have a lot of stuff going on. So we have a lot of z's, we have y's, we have x's. And the reason why we did this process, it's a very formal process, was that because it gave us let us do less operations, okay? So we could have easily just picked two different equations, add them together and try to solve it, and then just play around with them. But we want to be able to decrease the number of operations that we make, and this method will decrease the number of operations for the most part. So the way that Gaussian elimination basically works is that we want to be able to make something into an augmented matrix. And what that basically means is that you're going to have this matrix. So matrix is kind of like an array of numbers. And what you're going to write is that you're going to make it in a very formal way. So the first column, okay, so this is the columns are going to be kind of like these arrows pointing down. These are what we call columns, and the rows are going to be everything that's like in the horizontal way. So columns are vertical, and then the rows are horizontal. So let me write down a couple things. So the way that we write them, think about this first column is going to represent all the x's. This second column is going to represent all the y's. And this third column is going to represent all the z's. Okay, so what I mean by that is the coefficients in front of them. Here on this other side where there's a dotted line, here is going to be everything. So numbers after equal sign. So in the end, you're just going to get a whole bunch of numbers in here, in this matrix. Okay, so, and we'll formalize the idea of a matrix a little later. But this thing is what we call an augmented matrix. So this is an augmented matrix. So let me give you an example of how to augment a matrix. So we'll start off with an easy one. So let's say you have the system of equations, which is what we, oops, that's the wrong one. So let's say you had this system of equations, 2x minus y is equal to 5, and then x plus 4y equals to 7. Let's say you want to write that in an augmented matrix. So the way that we would do it is that we would have this matrix and then a line. And what we're going to do is that we remember that this is going to be all the columns for x's. This is going to be all the columns for y's. This all the columns for the left-hand side. So the first one for the x is going to be a 2. The next one's going to be this -1. Then the next one's going to be after the equal sign. That's going to be a 5. Then this guy's going to be a 1. This guy's going to be a 4. And this guy's going to be a 7. Okay, so this would be the augmented matrix. Okay, so what about if I had this type of problem? So let's say you had x minus 2y minus z equals 1, negative x plus 3y plus 3z equals 4, and then 2x minus 3y plus z equals 10. So how would we make a augmented matrix of this? Well, what we got to do, we're going to draw two brackets, and then we're going to draw a line, and we're going to go row by row. So it's going to be 1, then -2, whoops, 1, then -2, then -1. We're going to write this line, and then a 1. Then the second row is going to be -1, 3, and 3. So we're just looking at the coefficients, and then after that is a 4. And then the next one's going to be 2, -3, 1, and 10. Okay, so that's the augmented matrix for that system of equations. So the reason why we do that is because it makes it less messy. So we are rather, instead of working with the x's and the y's, we're just working with the numbers. So here are a couple things that you can do with these matrices. Okay, and usually the way that I like to write them, I like to write this one as row 1, row 2, and then row 3. So whenever you see R1, R2, R3, I'm saying row 1, row 2, row 3. We don't talk about the columns. The columns are just going to mess everything up. So the first thing is, these are some things that you can do with matrices. So the first thing that you can do with matrices is that you can add a multiple of one row to another. So kind of how we were doing it in the previous equations where you were multiplying it by one factor and then adding it to another one. That's basically what you can do. So you can add one multiple of each row to another, okay? Another thing that you can do, you can multiply a row, oh, I said that opposite, by a non-zero constant. Okay. So basically you can add rows together. You can multiply a row by a non-zero constant. So you can't it's not allowed to multiply by a zero on one of the rows. You can't do that. Another thing that you can do is interchange rows. So you can change the rows. So for example, if you wanted to switch these two rows, like row 2 and row 3, you can do that. You can swap them. That's perfectly fine. So you might want to consider doing that. So the whole point of this is that you want to make sure, so for a 2 by 2, so what I mean by 2 by 2 is that there's two rows. See how there's two rows and then two columns? Let's not worry about that guy. For a 2 by 2, basically what you want to be able to do is you want to get this to 0. So you want to eliminate that guy. For a 3 by 3, where you have 3 rows and 3 columns, let's ignore the right hand side for now, you want to make these guys into 0. And that process is what we call Gaussian elimination. So the whole goal is that you want to get this guy, so let me just write it like this. So something that looks like this, because all of these are going to have numbers. You want to get this one, you want to use Gaussian elimination. And what you want to get in the end is this. You want to get that, then a 0, star, 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 0, 0, star, star. That's what you want to do. This is what we call an upper triangular matrix. Upper triangular. So this is what you want to do. Later on, you can make the other one 0 as well, but that we're not going to talk about Gauss-Jordan. Okay. So this is kind of how you want to do it, because once we have it like that, then we can just back substitute it, just kind of how we did it with the previous problem. So we're going to start off first with a 2 by 2, and then we'll do a 3 by 3. Okay, so we're going to do first a 2 by 2. So let's say we wanted to do this problem. So use Gaussian elimination. Okay, so use Gaussian elimination to solve. So the first thing is going to be this 2x minus y equals 5. And then this x plus 4y equals 7. Okay. So the first thing that we want to do is put this into a augmented matrix. So we're going to write a 2 there, a -1, and then a 5, and then a 1, a 4, and then a 7. So because we have a 2 by 2, that means all we got to do is eliminate this guy. Okay. What you can do is you can swap the rows if you want. It doesn't really matter. So the way that I'm going to do that is I'm going to change row 2. Okay. So row 2 is going to be equal to, so I'm going to take row 1 and subtract it twice row 2. Okay. So that's basically using elementary operations. So the first one, the first row is not going to change. It's going to stay the same. So it's going to be 2, -1, and 5. And then the second row, what I'm going to do is I'm going to take row 1. I'm going to subtract twice row 2. So when I take that, multiply this by 2, 2 minus 2 gives me 0. You're going to get -1 minus 2 times that is going to give me 8. So that's going to give me a 9. And then you're going to take 5 and then minus 2 times 7. That's going to give me a -9. Okay. So now that we finally got this to be 0, now we can rewrite it as 2x minus y. So I'm just rewriting this first part because remember this was the x and this is the y, so it's going to be 2x negative y equals 5. And then the other one, notice that the x went away, so we're left with negative 9y equals negative 9. And notice that this is now really easy. Just divide by negative 9, y equals 1, and then plug that back into the original. 2x minus 1 equals 5. Add the 1 over. So we get 6, so x is equal to 3, which was the solution to the very first problem that we did. Okay, so this works. You can do this. It's a much more formal method. We're not using substitution or elimination, but we're still using the same methods that, you basically are using substitution. We did substitution and we're doing elimination, but in a much more formal way. Okay, so let's do one more example and then we'll do 3x3s. Okay, so let's say you wanted to do the same process to the system of equations. So 3x plus 4y equals 12. And then 6x plus 8y equals 24. So we're going to start off by writing an augmented matrix. So that's going to be a 3, a 4, and then a 12. And then you're going to have a 6, an 8, and then a 24. So the first thing that we're going to do is we're going to try to eliminate this guy. So we're going to use row 2. How am I going to eliminate this guy? Well, I'm going to use row 1. I'm going to use this guy. So I'm going to multiply twice row 1. Okay, so 2 times row 1. But now, what am I going to do? Well, if I add it to row 2, that's not going to do anything. But if I multiply this by a negative, then it'll make it negative and it'll go away. So I'm going to multiply the first row by negative 2. That's going to give me negative 6. And then add it to 6, that's going to give me 0. So the first row is going to stay the same. The second row, we're going to use the operation. So this guy is going to give me 0. Then we're going to multiply this guy by negative 2. That's going to give me negative 8. And then add it to 8, that's going to give me 0. Then I'm going to multiply this one. You're going to get negative 24. Added to that one, you're going to get 0. Uh-oh, we got a row of zeros. Okay, so a row of zeros, what that basically means, row of zeros, that means that you have a dependent solution. You have infinitely many solutions because what you get is 0 equals 0. So let me write it like this. So you're going to have the first one, 3x plus 4y equals 12. And the other one is 0 is equal to 0. Remember when we said 0 equals 0 is an infinitely many solutions? So what are we going to do? We're going to parameterize this. So the way that we're going to parameterize it, we're just going to set x be just x. And then we're going to take the equation 3x plus 4y equals 12 and solve for y. So I'm going to subtract the 3x over. So we get 4y equals negative 3x plus 12. And then we're just going to divide by 4. So y is equal to negative 3/4 x plus 3. So our solution is going to be x, comma, negative 3/4 x plus 3. That's how we were going to write the solution. So infinitely many solutions, what it means, I can plug in any value for x. All of these, this is the formula that I can plug in, and I'm always going to get a value of a point that satisfies these equations. Now, how do I know if it's no solution? So if it's no solution, when you do the problem, the row will be 0 and then 1, or 0 and another number, okay, or 0 and 2. And you can see that this guy's going to be 0 equals 1. That actually makes no sense. So whenever you kind of almost have a row of zeros, that's when you know that this is going to be no solution. Okay. All right. So in the next video, what we're going to do 3x3, which is going to be a little more complicated. And then we'll also do one which is dependent.